Hello, this is Dr. Mears, and today we are going to be learning about limits at infinity. The concept of limits helps us to understand the behavior of functions for extreme values of x. We're going to focus on rational functions such as f of x equals 1 divided by x squared. So let's look, we're going to be using this picture. This picture is from our function f of x equals 1 divided by x squared. Let's just label it a little bit. So we're going to label, this is going to be our x-axis, and this is going to be our y-axis. Okay, first, our horizontal asymptote, y equals k, tells you the behavior of the function for very large values of x. So what we're going to be looking at horizontally is going to be side to side. So this curve coming in from the right and going to the left is coming down, and it's going to get very close to the x-axis, but it's never, ever, ever going to cross it. And so this is known as the horizontal asymptote. And so we can see here that the horizontal asymptote is going to be at y equals 0. Y equals 0 is another way of saying x-axis. Vertical asymptote. Vertical asymptote, we're going to look to see what the graph is doing. When we're coming in from the left and going to the right here, what's happening to my curve? Well, my curve is going to try to get as close to the y-axis as possible, but never, ever, ever get there. That's the sad story in math. It tries to make it, but it's limited, and it will never make it. Similarly, looking at this curve on the other side in quadrant 1, coming in from the right here and going all the way up, we see, again, it's trying to get to that y-axis, but it's never, ever going to get there. So our vertical asymptote for this one is going to be x equals 0, which is our y-axis. So x-axis is another way of saying y equals 0, and y-axis is another way of saying x equals 0. So those are interchangeable. Okay. These asymptotes informs us about the limits of the graphs of the functions because they're never going to get there. They're going to try to get as close as possible, but they're never ever going to get or cross that x-axis. Okay, a couple things in order to be able to find our vertical and horizontal asymptotes are degree and coefficient of the degree. We need to understand what these are. So the degree is the highest exponent of a function. And I'm going to give you another function here just so that we can look at the numerator and denominator. We have x squared plus 2, and let's say we have 4x squared minus 3. Okay, so we're going to be looking at functions like this, and we're going to have to say what the degree of the numerator is and what the degree of the denominator is. So in the numerator here, the degree is going to be 2 because that's the x variable, that's the one with the highest exponent. So our degree is 2. Okay, looking in the denominator here, we also see that we have x squared, and that is the highest value, so our degree is also 2. So these are equal. The numerator and denominator degrees are equal. We're also going to need to be able to tell what the coefficient of the degree is. And the coefficient is the number in front of the variable with the highest exponent. So looking in the numerator here, we go to that highest exponent, the number is 1, so that coefficient is 1. Okay, if we look in the denominator, again, here's the highest degree, the number in front is 4, so the coefficient in the denominator is 4. So that's what I'm going to be looking for the degrees and the coefficients in the numerator and the denominator. Okay, let's move on. So we're going to be looking at 3 different situations. The first situation that we're going to look at is when the degree of the numerator is smaller than the denominator. I'm going to be using the symbol, the is less than symbol, so is smaller, is less than, okay? And then we're going to be looking at another situation where the degree is going to be larger, and we're larger than the denominator, so we're going to use the is greater than symbol. And finally, our third is going to be when the degree is going to be equal. We are going to be using the equal sign to the denominator. So let's get going and let's look at when it's smaller. Okay, We are going to have 3 examples to do. 1, 2, 3. Let's start with the first one, and let's see what I'm going to have to fill out and what they give us. First, they give us the equation. We're going to have to find the degree of the numerator, the degree of the denominator, the horizontal asymptote, vertical asymptote, and I give you the graph so that you can actually see that that it is true, these will be true for the graph of this equation. So let's move on. All right, so let's look. Y equals -2 divided by x plus 4. So we need the degree of the numerator. Now, if you notice, in the numerator, we don't have any x values. It's just -2. What that really means is that we actually have an x, but it's to the 0 power. Anything, remember, to the 0 power, x to the 0 is 1. 4 to the 0 is 1. So it doesn't appear there because -2 times 1 is just -2. So the degree here is 0 because there was no x. Okay, in the denominator, we see we have x plus 4. If you don't see an exponent attached to x, please remember that it's the number 1. So the degree is 1. So if there's no exponent, if there's just the letter x, remember there's a 1. Likely, if there's no coefficient, no number in front, that's also 1. So there we go. Okay, so let's see. Let's compare the degree of the numerator and the degree of the denominator, and we see that 0 is less than 1. So our vertical asymptote here, when the degree of the numerator is less than, your horizontal asymptote is always going to be y equals 0, which means it's always going to try to get as close as possible to the x-axis, but never, ever, ever cross it. And if we look at this picture, here is our x-axis, or our y equals 0, and if you notice, if we're coming in from the right here, going to the left, and it's going down, it's trying to get as close as possible to the x, and coming in from the left, going to the right, and we're coming up, it's trying to get as close to the x-axis as possible, but it will never make it. And we write that as y equals 0. Okay, how do you find your vertical asymptote? Vertical asymptote is x equals c. So what we're going to do is we're going to set the denominator equal to 0 and solve for x, just the denominator. So we're going to take our x plus 4, set it equal to 0, and we're going to use our algebra skills, and we're going to solve. And that's it. That's your answer. And so if we look at the graph, and I know it's a little fuzzy on your end, but this is -4 right here. Can't really see it. This was -2, this is -6, this is -8. So at -4, the graph is, again, going to try to get as close as possible, but never cross the line x equals -4. Okay, let's move on to the second one. Y equals the quantity x minus 6 divided by the quantity x squared minus 3. Now, the reason why I say the quantity is because that means that if you ever do this in your calculator, if you ever graph it, you have to keep the x minus 6 together. That is a whole quantity in itself. So when I say quantity, I'm really putting these imaginary parentheses around it. So if you do this in the calculator, if you ever substitute numbers in, please use the parentheses to keep the numerator together. Give it a hug with your parentheses. Keep your denominator. Give your denominator a hug with the parentheses so that the calculator knows that you want the numerator to stay together because it will not compute correct. All right, let's see. What's the degree of the numerator? If we look, we have x here, and that x is to the first power. And in the denominator, we see we have x squared, so we have no other x's, so that is going to be 2. We do see that 1 is less than 2, so the horizontal asymptote is going to be y equals 0 again. So at the x-axis, you do notice that it does get as close, oops, sorry, this one crosses, but this one right here is going to get as close as possible, but never cross. This one right here is going to get as close as possible, there's my lights, but never cross. It's just going to keep coming up and up and up and never ever cross it. So we have an asymptote of y equals 0. All right, let's do our vertical asymptote. We're going to get the denominator, set it equal to 0. So even if one crosses but the other doesn't, it still has a vertical it still has a horizontal asymptote because I know some people are like, wait, it crosses right there. But this is the graph that has it. This is part of the graph that has that horizontal asymptote. So just be careful. I wanted to go back and say that. Okay, so for this one, let's solve for our vertical. So plus 3 plus 3. So x squared equals 3. Now we have a square. In order to get a square, we take the square root. And you have to be careful with this because when we take the square root, we actually have two answers. We have x equals positive or negative square root of 3. What is that? Oops, square root of 3. What does that look like in our calculator? So we're going to turn this on and clear it out. So let's take the square root of 3. And so the decimal approximation is 1.73. So x equals 1.73 and x equals negative 1.73. So looking at this graph, both of these are going to try to get as close to 1.73. This side is going to try to get close to positive 1.73. This graph is going to try to get as close to negative 1.73. And so that's what it looks like. Now, why do we have positive and negative? Maybe that's a question in your mind. Well, I'm going to take a number, let's say, if we take the positive square root of 3 and multiply it by the positive square root of 3, we get the square root of 3 squared, which is 3. Perfect. If we take negative square root of 3 and multiply it by negative square root of 3, what we're going to get is negative square root of 3 squared. And what happens is because you are multiplying a negative by itself, or because you're squaring that negative, it turns to positive as well. Everything kind of drops out and you're left with 3. So we get two answers because when you multiply them, they both come out to be positive 3, and that's what we started with over here. So when you're taking the square root, you need the plus and the minus. Okay, let's move on. We have y equals the quantity of 5x plus x squared divided by the quantity of x cubed minus 8. Now let's look at the numerator. Notice this x is to the power of 1, but do we have another x variable there? Yes. And is it to a higher exponent? Yes. So we have to take that higher exponent. So be careful because they might not be in order. They might be rearranged. So you have to look for that highest exponent. And in the denominator, we can clearly see that the highest is 3. 2 is less than 3, so we have a horizontal asymptote at y equals 0. And we do see that the y equals 0, it's going to be this graph that's going to try to come and get as close to the x-axis as possible. So that's that one's asymptote. Let's find our vertical. Vertical asymptote, we're going to take the denominator, x cubed minus 8 equals 0, and we're going to add 8 to both sides. So we get x cubed equals 8. Now here, be careful, please. This is a cubed. So what we have to do is we have to take the cubed root. What that means is we have to find a number, the same number, that we can multiply by itself 3 times in order to get back to our answer of 8. And if you said 2 times 2 times 2, you're correct, and we would write it as x equals 2. Now, is there another way using the calculator that we could do this? Let's say our number is very large. Yes, there is. What you can do is you have to first understand that this is the cubed root. We have 8, and what exponent does 8 have? 8 has an exponent of 1. Remember, if the exponent's not there, it's 1. And so what happens is we can change this whole symbol to a fraction. We take the exponent, which is 1, and we divide it by the root, which is 3. So this is the exponent. This is the root. And so if we put it 8 to the 1/3 power in our calculator, so we're going to do 8. Here's your exponent button above the division, to the 1 divided by 3. Remember, just division. 1/3 is just 1 divided by 3. And we press enter, we're going to get the number 2. So we're going to get the same exact answer. So if you want to try to think of the number that we need to multiply by itself 3 times, you can. Or if you like that you want to do it 8 to the exponent divided by the root power, that's fine as well. Either way works, everybody. And so we see x equals 2. So we're going to go, here is x equals 2, and both of them have it. So they both try to get close to 2 as possible, but we'll never ever make it. All right, so this was when the numerator is smaller. Let's look up to see when the numerator is larger or greater than. So we have y equals the quantity of 4x squared plus 9 divided by the quantity of x minus 7. So let's look at the degree of the numerator. We see that it's 2. The degree of the denominator, that is 1. We see that it's greater than. When it's greater than, what's going to happen is our horizontal asymptote, we're not going to have one. None. It will cross. It'll be with any number. So there's none that it's limited to. Vertical asymptote, we're just going to take the denominator, again, same exact procedure, and solve. So x equals 7. So, and as you can see, 7 is going to be right here. And as you notice, for the horizontal this way, it's just this is all going to be going down, that's going to be going up. So there is no horizontal, but we do have a vertical at x equals 7. Okay. Second one, y equals the quantity of x to the fourth minus 12 divided by the quantity of negative x squared plus 36. In the numerator, our highest exponent is 4. In the denominator, it is 2. This is greater than, which means we don't have any horizontal asymptotes. But our vertical asymptote, we're going to take the denominator, negative x squared plus 36, and we're going to solve for x after we set it equal to 0. So we're going to subtract 36 from both sides. We get negative x squared equals negative 36. In front of the x squared is really a negative 1, so we're going to divide by negative 1. We're going to get x squared equals positive 36, which is great. Take the square root, we're going to come out with x equals plus and minus 6. And so on the graph, we see here's positive 6, and this is the graph that has, it's never going to get to positive 6. Here's negative 6, never get to negative 6. So there we go. Okay, next, y equals the quantity of 4 minus 2x plus 3x to the 5th power divided by the quantity 2x cubed minus 16. In the numerator, we see that the highest exponent, be careful because it is 5. Even though it's the last term, it still has the highest exponent. In the denominator, it's 3. This is going to be greater than, which means that it has no horizontal asymptotes. And you can clearly see that it's just going to keep going up. So it's not approaching any number, so it has none. And for our denominator, we're going to set it equal to 0 to find the horizontal ones. Add 16 to both sides. Divide by 2. X cubed equals 8. Here you have to remember it's cubed, so we have to take that cubed root. We just did this one, so the cubed root of 8 you should know is 2. So x equals 2, or you could have done that 8 to the 1/3. And this is 2 right here. You can see this line is 2. This is 4. This is 6. And you can see that it's approaching, but never going to cross. All right, let's do our last one, which is going to be equal. So when the degree of the numerator is equal to the denominator. So we have the first one, y equals the quantity of 5x minus 9 divided by the quantity of 4x minus 24. The degree of the numerator is 1. The degree of the denominator is 1. You can't say 1 is equal to 1, which is going to mean we're going to do some extra work. As you notice, I added some more columns. So in order to get to the horizontal asymptote, you have to find the coefficient of the degree of the numerator and the coefficient of the degree of the denominator. So that's where we kind of looped back to the first page where we have to look to see where the highest degree is, and that's this term right here in the numerator. And the number in front of x is going to be 5. And then we have to look at for the denominator. Here's the highest degree. The number in front of the x is 4. Now, in order to get the horizontal asymptote, you divide the coefficient of the numerator by the denominator. So we write y equals, please do not forget about the y equals. You will be marked off if you forget about the y equals. So it's y equals 5/4. So this graph is going to try to get as close to 5/4 as possible, but never make it. Okay, vertical asymptote stays the same. Just bring the denominator over, set it equal to 0, and start solving. 4x equals 24, divide by 4, x equals 6. So this one stays the same. This is 6 right here, and again, you can see both of them have that vertical asymptote. Okay, next one, y equals negative x squared divided by the quantity, x squared minus, oh, I'm so sorry, this should be a 5 here. X squared minus 5, the line cut it off. Okay, so this negative, what I'm going to do is I'm going to give it to the numerator. So what's going to happen here is it's going to look like this now. Y equals negative x squared divided by negative x squared plus 5. Okay, I'm going to use this one. I don't like when that negative is hanging out in front because you miss it. You forget about it, and it's one of those things that you cannot because we're going to need it for this column. All right, let's look at the degree. The degree in the numerator is 2. Denominator is 2. They are equal, which means we're going to have to find the coefficient. So this is where you put that 1 in front, and so the coefficient is really negative 1. That's what you miss, and I don't want you to miss it, so please just rewrite it with this negative being given to the numerator. And the denominator, this is also negative 1. So we're going to write our horizontal asymptote, y equals negative 1 divided by negative 1, and we can simplify here to y equals positive 1. If you can simplify like that, please do. This would be a decimal, so I left it as a fraction. So if you can divide it out, please do. Okay. And as we can see, this one's trying to approach 1, and this one, there is one over here. Like this one just is being cut off. There is one over here that's going to be going down to approach 1 as well. Okay. Next, let's do our vertical asymptote. So we're going to take that denominator, negative x squared plus 5, and set it equal to 0. Subtract 5 from both sides, negative 5. We're going to divide by negative 1. X squared equals 5. Take the square root. So x equals plus and minus the square root of 5. You do not need to change that into a decimal. I like the approximate answers. You don't need to split it. You don't need to write x equals positive 5, x equals negative 5. This answer is absolutely fine. And with a square root, you don't have to write the square root of 5, sorry. So when you do take the square root of 5, it comes out to be a little greater than negative and positive 2. So you can divide that out to check the graph if you would like, but I'm going to move on. And our last one, y equals the quantity of 5 plus 2x cubed divided by the quantity 3x cubed minus 81. As you can see, both are the degree of 3. So I'm going to look, here's my highest degree. My coefficient is going to be 2, the number in front of x. Here, my highest degree is 3, so the number in front of my x is 3. So my horizontal asymptote is y equals 2/3. You cannot divide that out to a nice number, so just leave it. And for my last little bit, 3x cubed minus 81 equals 0, setting the denominator equal to 0 so we can get that vertical asymptote. 3x cubed equals 81, divide by 3. Hopefully you're seeing that we are doing some of the same steps. X cubed equals 27. We're not done though. We have to take the cubed root, everybody. Cubed, little 3 right there. So what number 3 times itself gives you 27? If you said 3, you are correct. Or remember, in our calculator, we could have done 27 to that 1/3 power, and you would get 3 as well. Either way works, and then you can check everything out on this graph. All your asymptotes are there. Okay, so this has been limits at infinity. We've learned about horizontal, vertical asymptotes where our graphs are limited, they'll never cross, and I hope this helped. Thanks.